This is Hong Yuzhen from UC Merced. I'm glad to share our work, RetrieveGAN, image synthesis via differentiable patch retrieval. It is a joint work with Xinyin Li, Lu Jiang, Weilong Yang, and Mingxuan Yang. In this work, we aim to generate image from the scene graph representation. The input signal is a scene graph, which indicates the object in the scene and the relationship between objects. Here is a demonstration of our method. Given the input scene graph, our model learns to retrieve patch for each object from the real images. Our model then synthesizes the final image according to the retrieved patches. There are two challenges in our approach. First, the retrieval process is usually not differentiable since we need to sample from a discrete diffusion using the argmax operation. As a result, the retrieval process cannot be optimized during the GAN training stage to consider the realism of the synthesized images. Second, the selected patches need to be mutually compatible. For instance, an existing retrieval-based approach may select soccer player along with the baseball court, which should not appear in the same image. Here is an overview of the proposed RetrieveGAN model. Our contributions are in the retrieval process. First, we use the Gumbel softmax trick to make the retrieval process differentiable. Second, we design an iterative retrieval process to select mutually compatible patches. The Gumbel softmax trick involves two operations. Gumbel reparameterization enables us to model the discrete diffusion using the continuous diffusion. The softmax operation approximates the argmax operation in the retrieval process. Since all the operations here are differentiable, we can optimize the patch embedding function during the GAN training stage. Now, given the differentiable mechanism, how can we select mutually compatible patches? We design an iterative retrieval process to select mutually compatible patches. In each iteration, the core idea is to retrieve the patch which is most compatible to the patches that are selected by the previous iterations. We iterate this process until all the objects in the input scene graph are assigned with an image patch. After the retrieval process, we encourage the selected patches to be mutually compatible using a co-occurrence loss function. Specifically, we minimize the feature distance between the selected patches on the co-occurrence space. The co-occurrence mapping function is a pre-trained function using a triplet loss on the training images. The positive pair contains the patches from the same image, while the negative one contains the patches from different images. We conduct experiments on two standard benchmark datasets and compare to several state-of-the-art approaches. Since the retrieval process can be optimized by the GAN training, our method reports more favorable realism scores. Here we show an example qualitative results. Compared to the previous retrieval-based framework, our method can select more compatible patches which yield more appealing results. To conclude, for the scene graph to image synthesis problem, we propose a retrieval approach that can be optimized during the GAN training stage and selects mutually compatible patches for generating the final image. Thank you.